Welcome to lesson 10. Today we will be looking at superannuation and investments. These are some of the harder questions you will cover in 2-unit maths. Before we get started, I think you should understand what type of question this is, so you'll be able to recognize it if it comes up in an exam. In a nutshell, you know you're going to be covering this topic if you have a question where you're putting in money and the money is growing every year, every month, whatever. So you're putting money in and the money is growing, and you're putting money in regularly. So let's say, for example, you put in $1,000 into the bank every month. Every single month for 10 years in a row, you're going to put in money. And all of these investments that you're making, all of these money that you put in, every single one of them will be earning compound interest separately. Okay, I guess that's the key. But the thing to look out for is you are putting money in regularly for a long period of time. And you're not taking out any money. You're only putting money in. The money is growing. The money is not reducing, it's growing because you're putting money in, and each of those investments is gaining compound interest. Alright, so you'll recognize, if you remember what I've just said, you'll recognize this topic when it comes up in a question. Alright, so there's two methods of tackling investment type problems, okay, and I'll be covering both of them. The first is treat every investment as a separate compound interest problem, then apply a geometric sum formula to sum them up. So that's one way to do it, and I think that's the easier way. I'll explain in a bit. The second way to do it is treat as a single amount that is compounding, find the value for the first few time periods, and find a pattern and extend to the nth period. And I will cover these in a lot more detail, so you don't need to worry about it. Alright, so each of these methods has advantages and disadvantages. So this first way, you treat every investment as a separate compound interest problem. This is probably easier. However, it only works with investment type problems. And what I mean by that is the next topic that we are doing is the repayments. And you won't be able to use the first method with the thing that we're going to do next topic, right? And method 2 is basically the way that you'll be doing the next topic. So if you choose to use method 2 for this topic as well, you won't have to learn anything new for the next topic. However, it is far harder to grasp at first. Okay, it's significantly more algebra heavy. So it's up to you. However, I do recommend that if you understand one method, ignore the second method. Don't worry about it. As long as you understand one, you'll be able to do this question at least. Okay, this topic, and next topic, we'll get to that. So just make sure you're able to do this topic. Don't get confused by learning two different methods, and you get mixed up. Too many cooks spoil the broth, so to speak. Too many chefs spoil the broth. Anyway, so let's look at an example question. Superannuation is money put away each year for retirement. If $1,200 is put away at the beginning each year for the last 5 years at 8% per annum, how much do you get on retirement? So note here that we are putting in $1,200 every year, each year for the last 5 years. So every single year we're putting in money regularly. Alright, so if I was to draw a graph, this is basically what it would look like. So you have the first sum, right? You put in $1,200. You put it into this arrow represents I've put money in. Arrow pointing up will represent money coming out. And I strongly suggest that you draw a diagram like this to help you think through the problem. Okay, it does help a lot. It is optional. I don't think there'll be a question which will force you to do this kind of diagram, but still a quick diagram, I reckon it helps a lot. Anyway, so first sum of money we put in $1,200, right? Now this represents a timeline. I'm going to take the money out after 5 years. This is the first year, that is the second year, this is the third year, and so on. This is the beginning of the first year, this is the end of the second year, and the start of the second year. This is the beginning of the first year, end of the first year, and start of the second year, and so on. I hope you get the idea. So I put money in, $1,200 at the beginning of the first year. Putting money in, the beginning of each year. First year, second year, third year, fourth year, fifth year, right? And then at the end of 5 years, we took the money out. So this is the timeline, this is the money flow. Downwards arrow means money coming in, upwards arrow means money taken out of the bank. So the first sum invested will gain compound interest for 5 years. So let's think about that for a second. This money, this $1,200 that I put in at the beginning of the first year, right, is going to get compound interest for 1 year, 2 years, 3 years, 4 years, 5 years. At the end of 5 years, this sum will have gained interest for 5 years. So if I were to use the compound interest formula, A is equal to P R N. 5 years, right? 5 years. The second sum will gain interest for 4 years. 1, 2, 3, 4, right? So A is equal to P R N, right? So you can see 5, 4, it's going down. So the fifth sum that I put in at the beginning of the 5th year will get interest for 1 year. Therefore, PRN will be to the power of 1. So the sum of these 5 investments, if I were to write this out, it would look something like this. And we can spot that, you know, they each have 1,200 in common. So let's factorize that. We factorize the 1,200 out, and now we have 1.08 to the power of 1 plus 1.8 to the power of 2, and so on. And that is a GP. I'm sure you can recognize, right? That's a series. Sum of a geometric progression, sum of a geometric series, right? With A is equal to 1.08 and R is equal to 1.08. So A, R to the n minus 1 over R minus 1. You know, the formula that we've done for geometric series. Now, note, I'm only dealing with the red bit right now, only the GP stuff. The blue stuff I will have to add back in later on. It'll multiply with whatever we get over here. Alright, simplify that, or put in the calculator, and you get that as an answer. We multiply 1,200 by that answer, and that will give you the sum. That will give you how much money we will have on retirement. Easy. It's not particularly hard. However, it is long and lengthy, and you need to understand it, right? And as soon as you understand it, it'll be really easy. You have to work your way through a few of these questions. In fact, I suggest that you pause this video and try to do this very question. Just give it a go yourself, you know, see how you do. This is one of the harder topics in 2-unit maths, and I'm not saying that it's hard in that you can't understand it. It's hard in that it's very involved and it's very long. There's a lot of working out, a lot of things to think through, and you know, there's a lot of room for silly mistakes. Do not make the mistake of trying to rote learn this, okay? You should not be rote learning anything. Just think your way through it, make sure you understand it, and it'll all work out. Alright, let's look at the second type of superannuation question. So if $2,000 is put away at the end of each year, over here it was at the beginning of each year, right? Now, we're putting money away at the end of each year for the last 5 years, 7% per annum. How much do we get? Well, let's start with the diagram. Now, this is the beginning of the first year, this is the end of the first year, and the start of the second year. We're putting money away at the end of each year. So I've put money in over here, right? And that'll change how many years it gains compound interest for. That's really the only difference. And this will not get compound interest at all, because I put it in and I'm taking it out straight away. Hope that makes sense, right? Because we're putting at the end of each year. At the end of the 5th year, I put in money, but hey, I'm taking out the money at the end of 5 years as well. So this will not have time to gain compound interest. So let's just say we'll make 5 deposits and you get interest on them respectively for, this one's going to gain interest for 4 years. 1, 2, 3, 4, right? And then 3, 2, 1, and 0. So if we were to write an equation, right? PRN. A is equal to P 1 plus R to the n, compound interest. 4 years, 3 years, 2 years, 1 year, 0 years. 2,000 is common, factorize that out, and we have sum of a GP, right? So that's a GP, so we know that's the formula. Let's apply it, put it in the calculator, you get that, multiply it by 2,000, multiply this by 2,000, and you get your answer. Straightforward. So it wasn't that different really. It's just, you know, it's just a matter of understanding that this is at the end of the first year. The previous question was at the beginning of the first year, and that will change how many years it gains interest. So having a diagram like this will help you visually see exactly what's happening. So it's important. So please, you know, get into the habit of drawing a diagram, especially because this is a harder question, and you can expect this is going to be worth a fair few marks, and it'll be towards the latter part of the exam. So it's worth it to stop you from making a silly mistake. So here's an exam style question. A person invests $2,000 at the beginning of each year, so I'm going to underline that. of each year, and superannuation fund. And superannuation fund in general will imply this topic, I guess. Whereas if you have a repayment scheme or a loan, home loan or something like that, that will imply the next topic. You'll see after you finish the next topic, you'll see what I'm talking about. So anyway, assuming interest is paid at the rate of 9% per annum on this money, find how much the investment is worth at the end of 40 years. So yes, in the exams, it won't be 5 years, it'll be a lot longer, 40 years. We'll have to think our way through it. Alright, so let's start. The first $2,000 invested earns 9% per annum compounded interest for 40 years. I haven't drawn a diagram here, but you're more than welcome to give it a go. It looks something like this. This is one, we'll write one in the middle, right? We'll write one in the middle. And this will be the second year. And dot, dot, dot. Right, and 39 years. And 40 years there. Right, and I'm putting money in 2,000, right? 2,000 over here. Beginning of every year. So this is going to compound for 1 year, 2 years. See, 2. So over here it'll be 39 years, 40 years. So the first $2,000 invested will earn for 40 years. Let me just clear. Let me just clear it. Okay, so for 40 years, since it is invested at the beginning of the first year and we want its value at the end of the 40th year. Therefore, using the compound interest formula, this will grow to that. The second investment will be to the power of 39, right? So if you just write this out, right, you will see there's a pattern, 38th. So let's just write it out. 2,000 to the 40, 39, 30, dot, 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 all the way to 1, right? Now we can factorize out the 2,000. So it's not really any different to the question that we did, the first question that we did. Hopefully you can see where I'm coming from, why we can generalize like this. Because there's a pattern, and we've established the pattern. We've thought our way through it, and we've established a pattern. We can write the whole thing out like this. Now we're going to factorize out the 2,000, and then this is a GP. We use the sum of the GP to write it like this, right? R to the n minus 1 over R minus 1 multiplied by 2,000. Put this on the calculator first, simplify, put on the calculator, and you just get the answer. So not that hard, I guess. So far, I've only used the first way. We have treated each investment separately. So we've said that, okay, the first investment gains interest for 40 years, the second investment gains interest for 39 years. So we're treating each of these separately. And if you understand this method, I strongly recommend that you skip the next slide and you start doing the questions, I guess. Or you skip the next slide and see the slides after it. If you would like to see the second method, it is somewhat harder. Just bear with me, okay? So, Mr. Sharkey, this is something that I've thought out myself in real life. It's actually real. Mr. Sharkey wants to retire within 30 years. He calculates he can invest $1,000 at the beginning of every month. He invests his money into the stock market, which gives an average return of 8% per annum. Sometimes I will earn a loss. That's okay. On average, on other years I might earn 12%, 13%. So on average, 8% per annum historically for like the last 100 years or something. The stock market gives 8% per annum. Let's just say it's compounded monthly for the sake of this question, okay? I'm not saying it's like that in real life. Let's just say for the sake of this question, it's compounded monthly. Mr. Sharkey needs $1.5 million to retire. Will he achieve his target of retiring by the end of 30 years? Obviously, I've mixed numbers a bit just to make this an interesting, a good question, I guess. Alright, so the amount Mr. Sharkey has at the end of the first month will be $1,000 multiplied 1.0066. Now, if you're wondering where I got that number from, it's 8% per annum per year, but it's compounding monthly, so I have to convert that to per month. So 8% divided by 12, and then it's just PR plus 1. Right? Now, what I'm doing over here is the amount of money that I have at the end of the first month. Now, since I am investing at the beginning of every month, I'm investing $1,000. I invested $1,000 at the beginning of the month, and then it compounded once, right? It compounded once. I had $1,000 at the beginning. By the end of the first month, I gained compound interest. PR to the n. This would be 1 here, to the power of 1. Now, the amount of money I have at the end of the second month will be, well, whatever money I had already at the end of the first month will also compound. And since I put another $1,000 in, that will also compound. That is to say, let's say that's something like $1,100. Just for the sake of argument, okay? Imagine at the end of the first month I had $1,100. So that 1,100, M1, 1,100 will gain compound interest. Plus, at the start of the second month, I put another $1,000 in. And that will also gain compound interest. So this will become 1,100, for example, right? So that will get compound interest. And the new money I'm putting in will also get compound interest. And if I were to just, let's just substitute what M1 is. Substitute that. I'm not really worried about the exact value. I'm just going to put in, I'm just going to keep it like this without simplifying this expression on the calculator. So M1 is 1,000 times 1.066. 1.0066, right? So 1,000 times 1.0066. But because I was multiplying it by that, it'll become squared. Right? So M1 times 1.0066. So that's M1. And I multiplied by another 1.0066 became squared. And I haven't changed that. That remains as is. If I want to simplify it a bit further, I could factorize out the 1,000, right? And that's what I'll be left with. All right. So moving on to the third month. Mr. Shakir has at the end of the month 3 will be whatever I had at the end of the second month will compound, and again, as per normal, since I put money in at the beginning of the third month, that will also gain compound interest. Now, what was M2? I'm going to use that expression there. M2 was that. So I'm going to sub it in, right, and multiply by 1.0066. This bit here is that bit there. And that M2 is that M2 which we got from here. I've color coded it, right? Just put it in. Now I'm going to expand this bracket. I'm just going to expand. That's all I'm doing. Expanding. So I'm going to multiply this with this. So that'll become cubed. We've got cubed over there, right? That is going to multiply with this, and that's going to become squared. Become squared. Plus 1,000, which I haven't changed from there, right? So now I'm looking at this, and I'm going to factorize out 1,000 1.0066. I'm going to factorize that out. I'm sorry, I didn't factorize out the 1,000. That's what I was slightly confused before. I didn't factorize the 1,000. I actually factorized out 1,000 times 1.0066 from both of these expressions. Similarly, I'm factorizing out this expression from all three of these. And what do I get left with? Well, once I take out this from here, that's going to become, the 1,000 is going to disappear. I factorized it out, and that's going to become a squared because I took one of these away out of it, right? And that's going to become to the power of 1 with no 1,000. That's going to become to the power of 0. Anything to the power of 0 is 1. So we just factorize it. This is slightly harder. I understand it's very algebra intense. I did warn you at the beginning. But once you get the hang of it, it's okay, I guess. It's the same thing every single question. And you'll be doing this in the next topic anyway. I guess that's one of the advantages. Alright, so amount Mr. Shakir has at the end of month 360. Remember, it's for 30 years. And because we're compounding monthly, we have to convert that 30 years into months, which is 360 months. That's where I got 360 from. Now we're going to generalize. At month 2, I had that. At month 3, I had this expression. So at month 360, I can guess that it looks something like this, right? That's going to remain the same. Times by, and inside the bracket, see, this is 3 and became 2. This is 2 and it became 1. Right, so at 360, it's going to become 359 plus 358 plus all the way up to 1. 1.2, 1, and ended up with 1. So it's a pattern. We've established a pattern. Now we can generalize. We can fast forward up to month 360 and just use sum of a GP now. We're going to use sum of a GP. That is a geometric progression. If you write this out, this term first, this is the second term, and so on, we'll see that A is equal to 1 and R is equal to 1.0066. So A, R to the n minus 1 over R minus 1. Just put that whole thing into the calculator and you get your answer. So will Mr. Sharkit have 1.5 million? No, he won't have 1.5 million, but he'll be damn close. He'll be very, very close. 1.47 million. You know, I think that's good enough, to be honest, for Mr. Sharkit to retire. Alright, so the formula for investments is given over here. Now, I don't recommend you memorize, or it's up to you, you can memorize it, but don't depend on this to answer the question. Very rarely, right? Very rarely, it's very rare. Some questions will ask you not to work out the total amount. They'll ask you, okay, just figure out the nth term. And that's when you'll use this. But it's very rare. And one of those questions is actually over here, right? Like over here. At the start of each month, blah, 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 blah. Write down an expression for the amount of money in his super after n months corrected to the nearest dollar. You do not need to prove it. I'd put this in myself, right? But over here, you can, if you see the wording of the question, they haven't asked us to actually figure it out. They've just told you just write down an expression. And if that was a question, then you'd be able to use this formula. But that's very, very rare. You do need to know how to figure out this. You need to know basically the whole process. Whether you use it doing this way or the previous method, you do need to be able to figure it out. And I guess, you know, P is equal to amount invested each month, the principal every single month that you're putting, the regular deposits that you're making. R is the interest rate, obviously. N is the number of time periods. It's very straightforward. But you need to learn one of the two methods shown earlier to solve the question. It's not optional, you do need to know it. Anyway, let's just do the next question. At the start of each month, A Paul, I've got no idea where A Paul, cross that out. Paul invests $1,500 into superannuation. The account earns 10% per annum compounded monthly. Compounding monthly, so I need to convert that into per month, and 10 years I'll have to convert that into months. I hope you get the idea by now, okay? So write down an expression for the amount of money in his super after n months corrected to the nearest dollar. We can use the formula this time. You don't need to prove it. It doesn't say show or explain why. So, which is generally the case. They will ask you to show or explain why. Anyway, converting that into per month. This isn't time payments and investment superannuation type of question. I think we haven't even done time payments yet, so you don't need to worry about this. Anyway, so just putting into the formula. This is a formula, right? And that 1500 go to 1,81500 because this, I've simply done, like, if you divide by this, if you do 1500 divided by 0.0083, it'll actually get bigger. Just do it on a calculator. Check if you're confused. When you divide by a fraction, it's the same as flipping the fraction and multiplying. So whatever this is as a fraction, if you flip it and multiply, obviously this is going to grow, right? Anyway, you can do it on a calculator and you'll see. So that's the formula. Right, now the second question is saying calculate how much you will have after 10 years. Well, it's compounding monthly, so we need to convert 10 years into months, so 120. Right, now we just sub 120 into the formula and you get that. Put in a calculator, you get the answer. So you will have $309,828. Fairly straightforward, it's just calculator work. Alright, now the last part of the question. At the start of next year, this is where it starts to get tricky, right? At the start of the next year, Paul receives a pay rise and so begins to invest $2,000 into his super each month. Find, corrected the nearest month, how long it'll take in total for his account to reach $800,000. Well, the key here is at the start of the next year. So we have, if you were to draw a timeline, let's draw a new timeline, okay? And let's just say, so this is the 11th year. We're talking about the 11th year, right? 12th year, and so on, and blah, 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 dot, dot. And N, I don't know how, they're asking us to find how long it'll take, so it's going to be N years. And over here, I want 800,000, right? Sorry, I don't have my pen at the moment. Anyway, 800,000 and 11th year. So at the beginning of the 11th year, we had how much? Well, we had 309,828. So 309,828 will go over here. And starting from here, I'm going to put in $2,000. So that's going to be 2,000. I hope you understand that this is going to be, let's just call this Bn. Let's call this Bn from the previous equation, right? Bn. I've called it Bn. And that goes in. It's going to earn compound separately to these investments, which will earn compound interest separately. So B of n, I'll just wipe out the slide so we can actually see something. Bn is equal to 309828 blah, blah, blah to the power of n. That's going to earn compound interest separately, plus $2,000 times like the expression for that, right? We're using the formula in from the first part of the question, and we've just changed the values. The interest rate is the same. We don't know when. 121 after you divide by 2,000 divided by whatever was at the bottom over here. Just use the formula from the first part of the question. All right, and now we're just gonna have to use logs to somehow solve this. Now we need to find n when b is equal to $800,000. So we know that's going to be $800,000. That's going to be $800,000. So simplifying this, expanding the brackets and so on, we get that. Take that to the other side. And it's just a simple algebra problem after that, using logs basically. Divide both sides by 551828, right? Take log of both sides, n comes down. To that log on a calculator if you want. Divide by this log over here. Fairly straightforward. So 76.6. It'll take 77 months. Remember, we are dealing with months. We did convert everything to months, so don't think this is years. This is months. So take another 77 months or so. It'll take a total of 197 months for the account to reach $800,000. Total of 197, because the first 10 years plus from 11th year onwards, which is what we did in this question. And you will get $800,000 in a total of 197 months, or a further 77 months. Alright, so that's it. Do questions. I don't do questions 13 to 15. That's another worksheet. Just do the homework sheet that I put up. Just do it. Thank you and good luck.